Look at the ones that are like 10 through 15, okay? 10 through 15. There are two answers to those questions, all right? There are two answers to those questions. There's only one blank, but you need to put two answers. So first of all, it says find the value of C. It makes that a perfect square trinomial, is that what it says? And then it says then write it as a binomial square. Okay? So two answers, not one answer. 10 through 15. In the middle of the page on the front. Okay, now turn it over on the back. Look at the top. What number is that? 24. Okay, it says equal to 0, but down there in the blank, it's wanting you to put it in vertex form. So what do you need to replace the 0 with? A what? A y. Okay? So put a y there. It's not asking you to solve it. Okay? It's asking you to put it in vertex form and tell me what the vertex is. Okay? Anybody got a question? All right. So before we get started, this is what we're fixing to do. But before we get started with that, I wanted to work one problem that we had left on, that we didn't get done on the other, on 4.7. Okay, there's only one problem. So I'm going to, I've got to move that one. Here is the problem that we didn't do. I gotta find it. Okay, here it is. So this is the last bit of 4.7, and it is actually the problem example 7. So the first thing that I'm going to do is I'm going to talk about a formula that they give you. We see this quite a lot, and we use it in a lot of word problems, okay? So the formula is h is equal to negative 16t squared plus v sub o t plus h sub o. All right, so let me ask you, does anybody remember what h sub o means? H sub 0. Do you remember that I told you before?
Yes.
Okay. So, anything sub 0 is when time is 0. So that's at the beginning, initially, when the problem starts. All right? So this right here is my initial height. Okay? My initial height. This v sub o would be my initial velocity. Initial velocity. Okay? So we're going to be thinking, this is all, not all, these are some of the applications that you can use this formula for. Okay? If I threw a baseball, as soon as it left my hand, it would be going whatever speed. Okay? Does it always stay that speed until Landon catches it? Landon, he's not in this class. Does it?
No.
No, it doesn't. What happens to it as soon as it leaves my hand?
Slow down.
It starts slowing down. Gravity and things like that start pulling on it, and it starts slowing down. Okay? What about if you kicked a football off of a tee? Same thing, right? Same exact thing. Going to make that little parabolic motion. Okay, that's that square. So what about if you fired a bullet out of a gun?
Same thing.
Same thing. It goes out of the gun, and it's going really fast, and then it starts slowing down, slowing down, slowing down, and eventually it lands on the ground. Okay? Unless you hit a deer or something. What about shooting an arrow out of a bow? Same thing. It's all the same thing, guys. Okay, so those are just some of the places that you might see these used. This negative 16 right here has to do with gravity and things like that. That's physics. I'm not teaching physics. Okay? And this h right here, if this is my initial or beginning height, what is this?
The height.
The ending height. He's my ending height. Okay? All right. Now this is the problem. We're talking about a baseball. A guy hits a baseball. Okay? And it follows this path right here. Y is equal to negative 16t squared plus 96t plus 3. Okay? Y is the height. And X is my time in seconds. My height is in feet. Okay? So Y is the height in feet, and X is the initial, or is your time in seconds. So I'm going to ask you some questions, and just by looking at the equation, you should be able to answer my question. Can you tell me how fast the ball was going when the guy hit it?
96.
96 what?
Second?
Time.
Oh.
Not
Inches.
seconds.
Inches per second.
Huh?
Feet per second.
Thank you.
Feet per second, my bad. I'm like, I don't even know.
Okay, so my initial velocity is 96 feet per second, just like you would go miles per hour, but it's not, it's feet per second. We can change it to miles per hour. Do y'all remember that? It's called dimensional analysis. We did that in section 2 of chapter 1. All right, so can anybody tell me how high the ball was when he hit it?
3 feet.
That's exactly right, 3 feet, which is going to be right there in that strike zone. Okay, very good. All right, so here's what I want you to do. I want you to find the maximum height.
Didn't we do this?
Find the maximum height. Yes, we have done a problem like this. We sure have. So, what am I looking for? The Y when? Specifically.
The peak.
At the end of the problem, what's the height
When's
going
the
to
highest?
The highest.
be? At the highest point, what would that be called? Vertex. On a parabola that opens down, that would be called the vertex.
So you do it in.
So, we're going to complete the square and put it in vertex form. Are you with me?
Yeah.
So here he is, right here. So Y is equal to, what's the first thing that you do to it?
You see if it's a perfect square.
Take that negative 16 out. What do you multiply negative 16 by to get negative 16 squared? T squared. T squared, sorry. What do you multiply negative 16 by to get positive 96t?
6. Negative 6.
Negative 6. I'm also thinking that when I pull a negative out, he is going to change all these signs. So this guy became positive and that guy became negative. So negative 6t. Are you with me?
Yeah.
I'm going to close those parentheses and put my little 3 out here. Okay? I am thinking about this rainbow. All right? So let's complete the square. You ought to be working ahead. I'm lollygagging, taking my time. Okay? So what's half of 6?
3.
Squared?
9.
But did you really add 9?
No.
No. You really subtracted 144, right? So if you subtracted, because it's negative, guys, if you subtracted 144 here, what do you have to do out here?
Add 144.
So negative 16 times square root of the first, keep the sign, square root of the last, quantity squared. What's 3 and 144? 147? What's my vertex?
3 and 147.
3 and 147. Okay? 3 and 147. So, tell me what this vertex means, because I didn't ask you anything about a vertex.
That's the point on the.
What? Okay, so tell me
That's the
exactly
highest.
precise. What is?
The height.
Like the highest velocity. 3 is the time that it takes to get to.
Oh, I like that. Okay, so this Y value, this is my maximum height. Do you agree? Okay, I know it's the Y because it told me up here that Y was the height. and X is the time. So, like Lauren said, this 3 right here, this is how long it took to reach that maximum height. Okay, how long it took to reach that maximum height. Okay, so I'm going to show you what he looks like on a calculator. Hang on just one second. Just because I want to talk about it, okay? So here is my equation. I put it in, negative 16x squared plus 96x minus 3, all right? I'm going to go talk about the windows, all right? So x is my time. What's the smallest time, guys? 0, okay? What do you think, when's the problem gonna be over? We're thinking about, it's a baseball. Yeah, when it hits the ground, okay, we could say maybe it's over then, all right? So if it took 3 seconds to get to the highest point, how many seconds should I go to? 6? Maybe a little more? So, and I'm going to go from -1 to 7 because I want to see that axis in there. So I am going to go by ones. Okay? Now my y is my height. Obviously, 0 would be where it starts. Okay? The lowest that it's going to be. And the maximum, we already know. We found it. What was it? 147. So how about, I'm going to go to 150. And I'm going to go by 10, so I'm going to go from -10 to positive 150 and go by 10s. I'm only doing the negatives because I like to see the axis, okay? I don't like stuff to be on the edge. So I'm going to graph it. All right, notice that it starts right here at 3. That's really where my problem starts. It goes up and it comes back down. I could find this point right here, this vertex, by going second and calculate and choosing what? A maximum. Number 4. He's going to ask you for some boundaries. So I can't really see my spider, but he's up there. So I'll pull it. There he is. So he wants a left bound, so I'm left. Now he wants a right bound, so I'll get on the right hand side. So there he is. I don't want to guess, so I'll press enter. Okay? Now look what happened. Look what happened. Is this thing glitchy?
Yeah.
Yes. Y'all, what's the answer? 3. 147. Okay? They said 3.00000015. Okay? One period it was 17. One period it was 13. Okay? But we just call it 3. Huh? 2.999999978 or something like that. Okay? That's 3. Know what you're talking about. You're looking at a calculator. He does the best that he can. Okay? What if I said, how long does it take that ball to hit the ground? What would you be looking for?
The under
A 0, right?
Yeah, the x-intercept over here. And yes, they are called zeros. Okay? I can make my calculator find it, right? I could go second and calculate. What am I looking for? A 0. So I choose number 2. He still needs those boundaries. All right? So he wants a left bound. Where's the left bound of this 0 going to be? Above or below? Above. Okay, so here he comes. Down here's little spider. All right, so there he is. Give him a boundary. Now he wants a right bound, so that's going to be below. I'm not going to see him when he gets in that number, so I'm looking at this number and waiting until it changes to negatives. And then I'll know I'm below him. Because y'all listen to me. What that calculator's looking for is a sign change. If you got a sign change in your y's, you had a 0 in between there. Okay? That's going to come up later this year. Oh, stop it. Dang it. Sorry. All right, second and calculate. Stop. Sorry. All right, so there he is, left bound. Thank you for starting in the same place, Mr. Spider. There he is. I'm in the negatives. Gonna find a 0 between there. So there it is. 6.031 blah 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 blah. Okay? So, anybody got a question? All right, pretty cool problem. I want you to write this down. Okay, this is really what I want you to know. The y value is the maximum or the minimum. It's always going to be that way, guys. The y value is your maximum or minimum. The x value, and you can say it one of two ways, okay? You can either say the x value gives you the maximum or minimum, or you can say the x value is where it occurs, all right? I don't really care. So it gives the max or min, or it's where the max or min occur. All right, anybody got a question? Okay, all right, so here we go. Okay, all right, so now we're going to do 4.8. Now, here's what I'm going to do. I'm going to tell you exactly what is on your 50-point test that will be next Wednesday or Thursday. Okay, so you have a week. You can either memorize this. It's 8 steps. Okay, it's going to be difficult to memorize. So if you will just watch, I'll show you where it comes from, and I will derive it for you. All right? So we are going to derive, so you have a 50-point test, either Wednesday or Thursday, and it is derive the quadratic formula. Okay? Derive the quadratic formula. Do y'all think somebody just made the quadratic formula up?
I think somebody made math up as a whole.
Nobody made math up. Y'all discovered math, but nobody made it up. So this last class period, the kids said, yes, they made the quadratic formula up. Where do you think it came from? And I go, I'm going to show you where it came from. So first of all, let's just make sure that you know the quadratic formula. All right? You should know this. You did this in Algebra 1. X is equal to. I teach it with a little story, okay? While I first say the story, you'll be like, I'll never know that, but it doesn't take long. There was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. Okay, so here's the story. Y'all, my sister's kids made this up. Okay, my sister's kids made this up so that they could memorize the quadratic formula. They said, hey, can we make up a story so we can memorize it? She's like, yeah. So they made up this funny story. There was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. Okay? Now, I'm going to derive the quadratic formula. I hope that you can follow along with me. I'm going to do it by just taking an equation and completing the square to solve it. Okay? Should you know how to do that?
We should.
Okay, so I'm going to, at the end, I will box in everything that will be required on your test. I will give you a blank sheet of paper, and I will say, derive the quadratic formula. Okay? A blank sheet of paper. And so I'm going to number the steps. There's 8 steps. So there'll be about 6 points apiece. Okay? I'm going to number the steps because the kids asked me to. But then you don't have to number the steps, and the numbers are not something that I'm grading. So in the end, I will not put those in the box. Okay? So if you're wondering why the numbers are going to be way over here, it's because I'm not going to include them in the box. All right, so here we go. Very first thing, you're going to start off with an equation. I just want the standard quadratic equation. Ax squared plus bx plus c equals 0. You all know that. Does everybody agree? Okay, so for the second step, I'm doing everything in steps, okay? The second step, I want you to move C to the other side. So then it looks like this. Are you all with me? You got 12 points right now. Boom. We're doing so good. Okay? Now, if I'm going to complete the square, what's my next step going to be? That's exactly right. You have to factor that A out. Okay? So, my next step, I'm taking the A out. What do you multiply A by to get AX squared? What do you multiply A by to get BX? Remember what did I tell you to do? B over A. You take this number and you divide by this number. So B over A. Oh, there it is. So plus B over A X. I'm going to close off those parentheses. Equals negative C. Okay? I am going to draw this little rainbow thing, but you don't have to draw it. I'm not going to grade that part. Okay? It's just simply to remind me that when I get this thing right here, I need to take this guy into consideration. Okay, so now, how do I complete the square right here? Tell me what to do. Half of this guy. So here he is over here. I'm not doing stuff in my head. So I'm going to say times 1/2. What's B times 1? What's A times 2? 2A. Now what am I supposed to do with it? Square it. Okay? When you square a fraction, you square the top and square the bottom. What's B? B squared. So plus B squared. What's 2A squared? Yeah, 4A squared. I got to do it to the other side, but y'all, listen. What you got to multiply by A. So I'm going to go over here and see what it looks like. A times B squared over 4A squared. I'll put my little A over 1. Can I cancel stuff out?
No.
What? That's exactly right. I can take an A out here. You're left with nothing, which really means there's a 1, guys. And you can take 1A out here, so I'll just scratch out that square. So 1 times B squared is B squared, and then just 4A. So what am I doing right here? Plus B squared over 4A. All right, anybody got a question?
I thought you subtracted.
No, that's when you're on the same side. I'm on different sides. That's when you write it in vertex form. Okay? All right. So let's do number 4, step 4. Step 4 is I'm going to write this as a quantity squared, and I'm going to collect this stuff over here. That's my goal. Okay? So I got A times what? X plus,
B over 2A.
there it is right there, B over 2A. Or you could look right here and say the square root of B squared is B, and the square root of 4A squared is 2A. You can also look right here and say, what's half this guy? Quantity squared equals, over here, oh, I need to get a common denominator, don't I? Are you with me? So I got negative C plus B squared over 4A. So I'll put this over 1. What's a common denominator between 1 and 4A?
4A.
What do I do to that 1 to make him a 4A?
Times 4A.
You multiply by 4A. So I multiply the top by 4A. What's 4A times negative C?
4AC.
That's exactly right. Negative 4AC. Y'all, that's missing out on 4 awesome chicks. That's what that is. Negative 4AC. And then plus B squared. Now when we write it over here, we're going to flip it around. Okay? I wouldn't count it wrong if you didn't, but it'll help you if you flip it around because that's what it looks like. Okay? So I'm going to write B squared minus 4AC all over 4A. All right. Tell me what to do.
Divide by A.
I don't wanna divide by A because I got a little fraction over here. What else could I do?
Multiply by 1.
Yes, multiply by his reciprocal, 1 over A. So I multiply over here by 1 over A. Any number of times his reciprocal is 1, so he's gone. All right, so step 5, I'm only left with x plus b over 2a, quantity squared, is equal to. Y'all, what's 1 times anything? Just that thing. So b squared minus 4ac over, what's 4a times a? Now what do I do? So this square root simply removes that square. That radical removes that square. You with me? So I'm left with, this is step 6. X plus b over 2a is equal to, what's the square root of 4a squared?
2a.
Does that make me feel good? Because that's supposed to be the same as this denominator, and it is. So 2a, don't forget your plus or minus. You can't do anything up here, y'all. You cannot separate that b and take him out. Okay? If he's added and subtracted, you're not allowed to do it. If they're multiplied, you can. So, plus or minus the square root of b squared minus 4ac. What, Harrison?
Would it be for the whole fraction?
So plus or minus? It doesn't matter. You can put it over the whole thing or anywhere. Okay, so the next step, I'm going to take this guy and I'm going to pull him over here. So x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And then the last step, what am I going to do with those things? Yeah, I'm going to put them over the one denominator, 2a. And it's going to be, there was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. So this is what I'm looking for tomorrow. Not tomorrow. Sorry.
I was
Scared me.
Not tomorrow.
freaking out.
Sorry about that. So, not tomorrow. Next Wednesday or Thursday, all right? If I were you, I would go home and I would write it 3 times every night, just to make sure, okay? And see if you couldn't follow it along. But this is what it's gonna look like. You're gonna have to do that. Every time you miss something, you lose points. Okay, so do you want me to show you where some of the most common mistakes are made?
Not really.
Yes.
Yes. Okay, so these guys right here, a lot of kids leave those guys off. You'll lose 3 points if you do that.
Oh, wait. If
These
you-
guys right here. If you leave those guys off,
So you have to write absolutely everything.
everything that's in that box has to be written, okay? Another thing, sometimes kids forget to write that radical right there. They know what they're doing because they go from here to here, but they forget to write the radical. That'll cost you a point. This little square gets lost sometimes. I haven't ever figured out why that one does get lost, but I don't know, it just does. So that'll cost you 2 points if you drop him.
Every mistake you make is 2 points.
Every mistake you make is kind of like 2 points. Kind of like 2 points. Okay? All right. Everybody okay? All right. Tuesday or Wednesday, a blank sheet of paper. You will derive the quadratic formula. Yes, sorry.
You're trying to.
I don't know.
It's a hard part.
It's written right here, isn't it?
Yeah.
Did we write it down somewhere?
It's right at 50.
Yeah, Wednesday, Thursday. Sorry, I don't know. It's been a long day. I keep thinking today's Friday too, but it's not. You have to go back
No,
tomorrow.
no, listen, when we came into school this morning, I thought it was Tuesday.
No. Well, then you're having a very good day.
No, yeah.
Okay, quadratic formula. I'm gonna work one problem and then I'm quitting, okay? Quadratic formula, so that means you'll have the rest of the time you can work on your worksheet if you need to.
This is a rough day, we don't have to quit it.
Okay. So, y'all tell me the story, okay? X is equal to, tell me the story.
There was a negative boy who was kinda iffy. He went to a radical party. There was square dancing, and he missed out on 4 awesome chicks, and it all was done at 2 a.m.
Very good. Okay? Now, notice that it's all over at 2 a.m. So everything is over 2a, not just part of it, but all of it. Okay? So there's one thing that you do need to know, that in order for you to use the quadratic formula, your equation must be in standard form. Okay? Your equation must be in standard form. So if it's not in standard form, you have to put it. That's ax squared plus bx plus c equals 0. That means everything on one side, 0 on the other side, and all like terms collected. Okay? So here's our problem we're going to work. Example 1, it looks like this. X squared plus 3x equals 2. All right, so what's the first thing I need to do? Yeah, move that little 2 over. So he's in standard form. X squared plus 3x minus 2 equals 0.
Isn't it already kind of done a step for you though?
Do what?
We're solving it like we just did right here, huh?
No, we're solving it using the quadratic formula.
Oh,
Okay, we're not completing the square or anything. All right, so here he is. I suggest that you take the 2 seconds that it takes and you write down what does A, B, and C equal to, because that lends itself to make mistakes if you don't. What is A? 1. Okay, because it's the coefficient. What's B? And what's C? Very good. So I'm plugging my stuff in this formula right here. I want the opposite of B. Y'all, that's what we say negative B, but it really wants the opposite of B. What's the opposite of positive 3?
Negative 3.
Plus or minus the square root of. What's 3 squared? 9. See? B squared. 3 squared is 9. Minus 4 times A is 1 and C is negative 2. All over 2 times 1. I normally just go out to the side of my paper and do a little chicken scratch right here. This is 9. What's two negative signs are going to make a positive. I don't care about the 1. He doesn't change when I'm multiplying. What's 4 times 2? 8, right? And it's negative 4 times negative 2, so it's positive 8. What's 9 plus 8? 17. And on the bottom, what's 2 times 1? Can I simplify my radical? You see all that stuff is still coming up, okay? So you can't simplify your radical. Nothing reduces, because look, even if this were a 6 and this were a 2, you could not reduce it because there's nothing out here to reduce. So if you can't do it to everybody, you don't do it to anybody, and that's my answer. And we're going to talk more about this answer tomorrow when we try to finish 4.8. Okay? Anybody got a question?
No.
All right. So the rest of the class period, you need to get your worksheet out. You need to work on it. You got about 15 minutes, so that's pretty good. I'm gonna, Michael, will you go stop that video, please?
Put it on in it.
I have no idea.